When it comes to find the Thevenin and Norton equivalent of the circuit, we can simulate it quite easily on AWR. For example, the open circuit voltage and the short circuit current are easy to find through AWR, like we have simulated in previous videos. But finding the equivalent resistance is a bit tricky. That we'll understand later in this video. So let's get started and try to find the Norton and Thevenin equivalent of different circuits. In the first step of this tutorial, we are going to open AWR design environment, and here you can clearly see I've already made the circuit for you. I have named it example circuit, and in this circuit we have two voltage sources and couple of resistors. Now to find the Thevenin equivalent, you have to find the open circuit voltage between node A and node B. Now to do that, we have to remove or unconnect R3, which is a 10 ohm resistor. But we are going to this example circuit for a couple of more simulations. So I'm just going to copy that. So you have to just drag your mouse cursor, select all the components, Ctrl C, scroll down and paste it here. I'm just going to name it Thevenin equivalent. Now to hide this component or just make it unconnected, we have to just select the components and click over toggle enable. So this component is still there, but the node A and node B are not connected through that component. Now to simulate it, we have to first annotate for voltage and current. To do that, we'll just select the example circuit, right click, go to add annotation, apply for all the current and node voltages and click over OK. And next we can just run the simulation and we'll find the Thevenin equivalent on this circuit, which is a 5 volt. Similarly, if you want to find the Norton equivalent, so that is another simple calculation and simple simulation using AWR. Now to do that, we'll again copy this entire circuit, Ctrl C, scroll down, we'll place it here. Now if you know what is Norton equivalent, Norton equivalent is just opposite of Thevenin. So instead of open circuit, we have to make it short circuit. To do that, we'll remove this resistor and connect it directly. Here we go. Or we can just change the value of resistor to 0 ohm. Okay, that is another way to do that. Again, since we have already annotated, we'll just click over simulate button. And here we go. So we are getting the short circuit current is 625 milliamps, which is as per the calculation, right? Now when it comes to find the equivalent resistor, we have to use exactly same technique irrespective of the dependent or independent sources. So currently we have independent sources, but in case we are using independent, we have to still do the same thing to find the equivalent resistors. And to do that, we have to just bypass these voltage sources and we have to use our test voltage. In our case, we are going to use 1 volt. So first quickly, we'll just copy this entire design. Let's copy the example circuit. All right, we'll place it somewhere here. And again, toggle that. Now in place of this resistor, we are going to use a voltage source, which will be a test voltage source of 1 volt. Let's connect that. And we have to bypass other voltage sources, either these are independent or dependent. So we'll make it like this. So it's the same thing, all right? So we are sort of bypassing these voltage sources and we have the test source here. Now we'll do the simple calculation. So here we'll have these 8 ohms connected parallel to a 1 volt voltage source, which is a test source in our case. If we'll do the analysis, we can simply calculate. So the voltage is 1. So we have to calculate the equivalent resistance. All right. So voltage is 1 volt and the current is 125 milliamps. If we'll apply the Ohm's law, we'll get R is equal to 8 ohm. So we'll get the unknown resistance 8 ohms connected to the source. So this is how you can find the Norton and Thevenin equivalent of any circuit. You can make it more complex, but I've taken the simple example. In the next video, we'll talk about frequency response simulations of a passive circuits. So next we are going to save the project. To do that, we'll go to File and click over Save Project. Go to Desktop. We are going to name it Norton underscore Thevenin equivalents and click our save button. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.